Hello there. I'm Carlos from the dev team at Fiveonefour. Welcome to the second part of our Brainwave demo. In this demo, we'll look at using the AI-based Aurora MCP server to analyze the brainwave data stored in our ClickHouse database. This is the Moose templates page where you can install this and other complete demos to quickly check out Moose in action. Here we see our brainwave demo template. Click on the View Template button to learn more about it. And here are the install and setup instructions. It's just a few standard commands, and I'll quickly step through it here. But before I do, just a quick reminder to check out the first video in this series for background on how we got to this point. Okay, here we go. Make sure to view our Moose docs in GitHub repo for the most up-to-date changes and install directions. Okay, done. Now let's install the Aurora MCP. Nice. Now we'll go back to our BrainMoose folder and run the Aurora setup command. This command basically sets up Aurora in a pre-existing project. Cool. Now we'll set up our Aurora tools. We'll select all of the tools out of convenience. Now Aurora reminds us that we need to update our MCP.json file with the ClickHouse variables. When you start Moose, it fires up a Docker environment, which includes a local ClickHouse database. We'll update those next in Cursor. When Cursor starts, we'll load the Cursor settings page. Next, we'll select the Tools and Integrations page. Here you should see Aurora activated. If you expand the Tools view, you can see the various MCP tools that Aurora offers. We can click on the pencil icon to edit the related MCP settings. Here we see the ClickHouse environment variables we need to update. But before we do that, this is a good time to point out that if you're trying this at home, you'll need to plug in your own Anthropic API key. Next, you can pause the video and copy these local ClickHouse settings. With data loaded into ClickHouse and Aurora MCP loaded into Cursor, we're now ready to use AI to analyze the loaded data. What a great time to be alive. Before we continue, let's see a brief recap from the first demo. During the first demo, we had our software ingest brainwave data into ClickHouse. Here's a video clip showing brainwave data being loaded from a CSV file into our ClickHouse database. Check out the first video for a play-by-play. Let's start Moose in dev mode, which will in turn load our Docker containers, including one for our local ClickHouse database. Let's begin by asking Cursor to read our ClickHouse brain table and describe the table schema. The problem with this prompt is that we're not telling Cursor what the name of the brain table is in ClickHouse. So Cursor scans our Moose project in search of the table name. Having located the table name, it continues and realizes that the Aurora MCP has a tool to read ClickHouse tables, so it calls that tool. Here we see that the call was successful and a response is being considered. Scrolling back a bit, we can see the table details and the brain table's column types. Now that we know that the table can be read, let's try something much more ambitious. Let's ask it which brainwave frequencies have the highest overall values. I need to call out that the entire brainwave data isn't being sent to an LLM. The table has tens of thousands of data points. Instead, the Aurora MCP is querying the data locally using an LLM-generated query. Also, Aurora is using Claude internally, while Cursor is using GPT-5. Despite my embarrassing grammatical error, we still get valid results. Here we see that the beta and alpha brainwave frequencies are the highest, but what does that mean? Let's find out. If you watched the first video, you may recall that I loaded brainwave data for a coding session. And the LLM correctly identified the brainwave data as likely being from a programming session. The code I was working on at the time was particularly challenging, and the other activities shown would not have been a good match. Pretty cool, huh? This entire project, including my actual brainwaves, are open sourced. We hope you enjoyed this brainwave hack using Moose. Check out the entire code for this demo, Moose, and our other open source projects. If you enjoyed this hack, drop us a GitHub star. It helps share our work with the community. That's it for now. Thanks for watching.